Hey y'all, welcome back. This is the second of the two videos on averages. In this one, we're going to be looking at two special kinds of averages, which are average rates and weighted averages. So let's say you want to make a big batch of trail mix. You want to divide that big batch up into smaller batches, maybe a pound per bag, and sell those to whoever wants to buy some. When you go off and make your big batch of trail mix, you're going to have a bunch of different ingredients, chocolates, nuts, pretzels, whatever you want. Right? And that's going to cost some amount of money. If you want to know how much you should be pricing this trail mix at, right, you probably need to know what should be the price per bag, per 1 pound bag. Right? And this is where average rates can help us out, right? We know what the cost of that big batch of trail mix was. Maybe that was several pounds, right? Average rates can help us figure out what is the cost per 1 pound bag of that trail mix. So let's just take that large quantity and figure out, all right, how much should it cost per unit, right? You can think of this as a kind of a unit price that you want to sell at. Okay. Another example would be figuring out what's the population per square mile in Massachusetts, a very large area, but I could figure out, okay, what's on average, how many people live in each square mile, right? A smaller unit of area. Okay. Or what's the time per mile for a certain swimmer who's going to be swimming a very long way, perhaps at various rates. Okay. Let's dive a little bit more deeply into that trail mix example. All right. So let's say you want to make a big batch of trail mix, right? This is going to be done by mixing a bunch of different ingredients, maybe 1.5 pounds of peanuts, which costs $2.50 per pound, 3/4 pound of almonds at $4 per pound, 1/2 pound of chocolate chips, 1/4 pound of dried cherries, 1/4 pound of cashews. In order to price these smaller bags of 1 pound each of trail mix, you need to know, well, how much does a pound of trail mix cost to make? Okay? So that's what I want to figure out here. And I really like talking first about what's the wrong way to do this, because I feel like oftentimes in math, there's kind of a knee-jerk reaction for how to solve these kind of problems. I think the knee-jerk reaction here is to just say, well, it's some kind of average. Let me just add up all of these price numbers I see and then divide by 5, the number that I have. Right? That's not going to work here for a couple of reasons. Right? The first problem is that, as we'll talk about later with weighted averages, all of these numbers are not equally important. Right? So we're putting in 1.5 pounds of peanuts, right? So a lot of peanuts, and not so many cashews, right? So it would be weird to average the 250 and the 8 as if they were equals in this calculation. The other problem is if I add all these up, that's the cost of making quite a large batch of trail mix, right? And I'm trying to figure out what's the cost of just 1 pound, right? So for a couple reasons, this is not going to work. So let's take this step by step. First, how many pounds does this recipe make? Well, we're using 1.5 pounds of peanuts, 3/4 pound of almonds, right? Basically adding up all of those different ingredients, how much of each one we were using. When we combine all of that, all of those weights will come together to make 3.25 pounds of trail mix. Okay, well, how much did that cost? Right? For the peanuts, right, we bought 1.5 pounds of them, and they were $2.50 per pound. Right? So if I take 1.5 pounds times the 250, that's going to give me how much that 1.5 pounds costs. I could do the same thing for all of the other ingredients, right? Basically taking 1.5 times 250 plus 0.75 times 4 plus 0.5 times 6 and so on. And that's going to total up to $14.50 for this big batch of trail mix. Okay, so in summary, we spent $14.50 to make 3.25 pounds of trail mix. Now, we want to know what's the average rate, right? What's the cost of 1 pound of trail mix, right? Well, if I want to find that out, I really just have to take, 3.25 pounds costs $14.50, right? Well, if I want to figure out what 1 pound costs, I really just have to divide, right? Divide that 14.50 total up into the 3.25 pounds is going to give me the price per pound. So here's what we just did. Right? If you're trying to figure out the average rate of something, right, which is often going to be asked of you in the form x per y, there's 3 steps. First, figure out how much x you have, so how much money it costs, how many miles it swam, how many people there are. Total your y number, how many pounds it was, how many hours it took, how many apartments there were. Right? And then divide your x total by your y total. Okay, it's that straightforward. So let me give you all a turn on this. Right? Let's say a swimmer has the following morning routine. She swims 0.4 miles of freestyle at the pace of 25 minutes a mile, 0.3 miles of breaststroke at 30 minutes a mile, and 0.2 miles of backstroke at 27 minutes a mile. Okay? I want to know, what's the swimmer's average time per mile during this routine? Okay? So take a second, try to figure that out. We'll go over the answer in a second. Feel free to use those 3 steps we have on the previous slide. And put your answer on the form. Okay, so we want the average time per mile. That's an average rate. Let's follow our 3 steps. First, we need to figure out this is x per y. Let's figure out how much x we have. How much time did this take, right? And for each of those strokes, it took her a different amount of time, right? For freestyle, she was going 0.4 miles at the rate of 25 minutes per 1 mile, right? So think back to our proportions section, right? We're trying to convert miles to minutes, right? And this is the way we do that. Right? So this ends up being 10 minutes taken to swim the 0.4 miles. Similar calculation using the breaststroke speed, right? And the 0.3 miles gives us 9 minutes for that stroke. And similar for backstroke is 5.4 minutes. So totaled up, she swam 24.4 minutes. Step 2. How much y do we have? This is average time per mile. How many miles did she swim? This is actually a pretty simple step, right? We know that for the first stroke was 0.4 miles, second one was 0.3, third one was 0.2. She swam 0.9 miles. Last step, divide those 2 quantities, right? The time spent was 24.4 minutes, and over that period, she went 0.9 miles, right? And that's going to give us 27.11 minutes per mile, okay? And that's average rates. Okay, the other topic I want to chat about is weighted averages, right? It may be that when you're trying to find the average of something, the things that you are trying to average are in some sense not equally important, right? For instance, if you're trying to calculate your grade in a class, the homework score usually carries less weight than an exam score, right? So you wouldn't want to just add your homework plus your exam score and say, well, I guess that's my grade, right? You have to keep the importance in mind. Right? In this case, we need to use a weighted average. This is just a kind of average that gives each number that we're averaging a level of influence proportional to its importance. The more important it is, the more weight it carries. So let's continue with that grading example. Let's say that you are in a course where this is what the rubric looks like. Here are the weights of the different assignments, right? And you're at the end of the course. These are the grades that you have achieved on those assignments, right? We can't treat these scores equally though, right? I'm not allowed to just take 85 plus 100 plus 82 and divide by 6 here, right? Because the homework scores are not as important as, say, the final exam score. So don't want to do that. Right? Instead, we need to weight, and in this case, I'm going to multiply each score by its importance. Right? The more important it is, the larger a number I'm going to multiply it by. Right? So here, importance equals these weights that were given over here. Right? So if I want to calculate the weighted average, I'm going to take that 85 and multiply it by its weight, the 14. Then add the the score of 100 on the labs, multiplied by this 10% weight, right? And basically take that sum, this times this, plus this times this, plus this times this, all the way down. And then I'm going to divide by the total of the weights, right? So I'm not just going to add up how many of these I had. I'm actually going to figure out what was my overall sum of my weights, right? So I'm going to add up this column here. Should get me an 87.18 as your grade in the course. So in general, this is going to look kind of nasty, right? If you have a collection of values, V1, V2, V3, right, and a collection of weights of importance for them, W1, W2, W3, right, the weighted average of these is going to be take each weight, multiply it by the value it corresponds to, right, add all of those up, and then divide by the sum of those weights. That's basically, this looks nasty, but this is basically what we just did. So I'm going to give y'all a couple of chances to work some of these problems. Let's say that you have not taken the final exam yet, right? And you want to know what is your current grade in the course going into the final, right? How can we find that? And try to answer on the form. Remember, I don't know is always a fine answer. Okay, so note that our weighted average formula doesn't say that the weights have to add to 100. This is maybe the most common piece of new information for students on this module. Those weights, they don't have to add to 100. We're kind of used to them doing that because that's how rubrics usually work. But if we only know all the scores preceding the final exam, well, let's just use only those scores and the weights associated with them, right? So let's take each weight, multiply by its score, right? Just like we were doing before, and add all those up. But there's going to be no final exam score down here, right? We're omitting that. Similar for the weights, right? There was a big 22 occupying where the final exam weight was, right? That's not there anymore. So we're going to take the sum, and now instead of dividing by 100, we'll divide by 78, right? Because we are now missing that 22% of your grade that the final exam made up. And that's going to get you an 88.08 going into the final exam. Okay. Last question, right? You have an 88 now. Can you still get a 90 in this course? And if you can, what do you need on your final exam to get a 90? Answer on the form. All right, this is going to be fairly similar to what we just did, right? We're going to take, once again, each weight multiplied by the score, add all those up. Now, we are trying to figure out what you need on that final exam. We don't know that right now, and when we don't know quantity, we're just going to call it a variable. Let's call it x, right? This is how we would normally be calculating your grade in the course. We've just replaced your final exam grade with x because we don't know that. We're going to divide by 100 here, right? Because this calculation is, we're pretending like it's being made after your final exam, right? If we know your score was X, right, then that 22 weight needs to be included down here so that we're dividing by 100. Right? So we're hoping that after this calculation, we will get a 90, right? We need an X that leads us to get a 90 here. And all it is now is just solving this, this equation. Right? Let's multiply both sides by 100. Right? And then combine all of these numbers here, or simplify them and then combine them. Right? Move this to the other side, divide by 22, and we see that you need 96.82 points on the final to get a 90 for the course. Okay, pretty practical calculation to know how to do if you are going to be in school for the next few years. All right, that is it for this video. Make sure you are filling out and submitting that form, and I will see y'all soon.